Next important topic in a transformer will be losses in a transformer. The question may ask in a question paper, explain the different losses in a transformer. So basically there will be two types of losses in a transformer. The first is an iron loss, second is called as an copper loss. So the first one is an iron loss. The iron loss is also called as an core loss because this loss is present at the core of the transformer. Again, the iron loss is also classified as an eddy current loss and hysteresis loss. Eddy, the meaning of eddy will be small, so that is a small current loss, and next will be hysteresis loss. These two, eddy current loss as well as hysteresis loss, both will occur in the iron, that is core of an transformer. So that is a square box as shown in the construction, so that is called as an core loss. So eddy current loss and the hysteresis loss both occur in the core of an transformer, hence these two are the types of an core loss. So the eddy current, so the outer cover, the square box which is present at this construction of an transformer, so that is made up of an silicon steel. If any small holes present over that construction, so inside the whatever the current will be, the small amount of the current will be flows outside of that core. So this loss is called as an eddy current loss, and this eddy current loss is calculated by We is equal to beta into Bm square F square T square into V. So as I explained everything, Bm is a maximum flux density, F is a frequency, T is a thickness, V is a volume, and beta is a constant. The question will be, in the answer we should write what is the definition for the loss and what is the equation and how to overcome. As I told itself, the core, outside of the core, if any damage is present, the current flows outside the core of a transformer. So to avoid that, we should do the laminations of high permeability magnetic material, example a silicon steel or a coated with the varnish. So this we can avoid the eddy current loss. Now second type of an core loss is an hysteresis loss. This loss is occurred because of the magnetization. So magnetization is nothing but whenever the current flows across the coil produces the flux. So this is we can call as a magnetization, and this hysteresis loss is calculated by WH is equal to eta into Bm raised to 1.6 into F into V. So here the WH is hysteresis loss, Bm is a maximum value of flux density, F is frequency, V is a volume, and eta is a constant. Then how to overcome this? How hysteresis loss? By selecting the minimum value of a constant. So the constant I given in the notes, 0.025 for the cast steel and 0.001 is for the silicon steel. So which one is having a smaller value? 0.001 is a smaller value. So better we should use the constant of an silicon steel to avoid the hysteresis loss. Now the second main classification of a loss is a copper loss. This copper loss is occur at the winding. This copper loss is occur at the winding side because the windings are made up of obviously the copper, so hence the name will be copper losses. And this losses occur because in practical transformer, the resistor R1 is connected at the primary side and the resistor R2 is connected at the secondary side. Because of the resistance, the current can opposes the flow of the resistance can opposes the flow of current. So this loss we can call as an copper loss. So the total copper loss we can call as an copper loss in a primary and the copper loss in secondary. So next time written WCU is equal to I1 square R1 plus I2 square R2. So this one we can use to calculate the copper loss also. Next time written I1 square into R01. The R01 is represent the absence of R2. Similarly third one, I2 square R02 E represents absence of R1. So basically there will be two losses. One is an iron loss. Again iron loss is classified as an eddy current loss, hysteresis loss. Next loss will be copper loss. Remember, in answer first we should write the statement of an loss, next equation, parameters used in equation, and how to overcome the losses. So next, one more important question in a transformer, derive the condition for maximum efficiency of a transformer. So this here, so efficiency is actually calculated by output divided by input. So already we have input power is V1 I1 cos phi 1 as similarly EI cos phi. So V1 I1 cos phi 1, the suffix 1 is using because of input is applying for the primary winding of a transformer, so the suffix 1 is using. So we are applying the input, but we don't know how much output we are getting at the output side of the transformer. So better to measure the more accuracy, we are going for one more efficiency formula, that is eta is equal to input power minus losses divided by input power. Next, losses will be two types here in transformer, so that losses is copper loss and iron loss. Next step, I'm substitute the formulas. Input power will be V1 I1 cos phi 1, copper loss is nothing but I1 square R01, copper iron loss is written only Wi input power. Next, dividing separately, next differentiating with respect to I1, I got it. Next, for efficiency is maximum, will get LHS d eta divided by d I1 is equal to 0. By substituting LHS is equal to 0 and making the arrangement, we got the equation Wi is equal to I1 square R01. Here Wi is nothing but the iron loss and I1 square R01 is nothing but the copper loss. Remember, transformer efficiency will get the maximum when both the losses are equal. Both the losses are equal. In problems also, if the word maximum comes, so we should use iron loss is equal to copper loss.